This video is about the materials water-fed poles are made from and how that affects your business and workers' performance. As a window cleaner, you are the machine and your muscles are your power. Your goal is to transfer 100% of your power directly to the brush, and you do that transfer through the water-fed pole. Now, while all poles look the same, they do not behave the same. Some are rigid, some are floppy, and that affects how efficient you're cleaning windows. When it comes to cleaning windows, you like to flex your muscles, but you do not want your pole to flex. Pole flex is the loss of effort from your muscle flex. Now, often a boss, when choosing a pole for his or her workers, will seek to save money on their workers' tools at the expense of the workers' efficiency. We hear from bosses that this is often on the basis that the worker does not look after their tools, so why spend big money on them? Whilst this low tool cost culture is very real in the window cleaning industry, if it can be overcome, you, your company, and your workers can all earn more money per hour. Now here's the conundrum. Window cleaner workers are not cheap to hire. A cheaper, floppier pole delivers lower worker efficiency. Therefore, the cheaper the pole, the more expensive the worker becomes on every job. By spending more money on a more rigid pole, your workers will work faster, and therefore the labor cost is lower on every job. Cleaning windows faster means you can add more jobs to each day, and by the end of each month, everyone is going to be making a whole lot more money. For those who can't afford the more rigid poles for their application, we say, well, any water-fed pole is better than no water-fed pole. Like any water-fed pole is better than climbing a ladder, right? This is why we're not saying wait until you can afford a rigid pole. Work is a process of continual improvement. If you must use a flexing pole today, you can plan to increase your efficiency with a more rigid pole in the future. Either way, you are the machine driving the water-fed pole, and you'll get more out of your muscles using a more rigid pole. So, when does a water-fed pole flex, and why? Well, let's start with what happens when we're cleaning ground floor windows. It's nearly impossible to get a pole to flex at this height, as there's not really enough load on the pole. The higher you clean, and the further away from the building you get, the greater the load, making the pole want to flex more. Now, whether it flexes or not is determined by what the pole is made from. So let's get into the technical stuff. As I said before, whilst all poles look the same, they are not the same. In order for you to know what you're buying, it helps to know all the options. Water-fed poles are available from a range of manufacturers made from different materials at different price points. A manufacturer will design a pole with a level of rigidity to be affordable at a certain price. Starting with the least expensive and the most flexible, the cheapest are aluminum poles. Then there's fiberglass. It's a cheap woven material that is heavy and not very rigid. Fiberglass has a low level of rigidity. Now, rigidity is the closest layman's term for what we manufacturers call modulus. After fiberglass, there's intermediate modulus carbon fiber, high modulus carbon fiber, and then the maximum rigidity is achieved using ultra high modulus carbon fiber. Now, here's something you might not know. A manufacturer can even change the composition of each pole section, so there's a different rigidity in each section, and therefore change the behavior of the pole overall to match the price with the maximum working height of the pole. The longer length the fully extended pole is, the higher the modulus is required to deliver optimal rigidity. Some manufacturers promote the lighter the pole, the better it is. Well, when you hold a lighter pole, you're holding less carbon fiber. This is because there's no such thing as lighter carbon fiber. Each section of a pole is made from between 5 and 8 layers of carbon fiber, depending on the manufacturer's recipe. 5 layers makes a pole lighter than 8 layers, but it also makes the pole more prone to breaking. Now, as replacement sections are really expensive, the choice between a pole with 5 layers or 8 layers may be influenced by whether you are an owner-operator or whether you have workers cleaning the windows. Oh, and there's one more popular composition in the window cleaning industry that we call hybrid. A hybrid pole is where one or more layers of carbon fiber are added to a fiberglass pole to make it more rigid than a 100% fiberglass pole. But the main ingredient is still fiberglass. Now, the reason for this is to keep the price of the pole lower, and as a result, they're still quite flexible. If the carbon fiber is added to the outside of the fiberglass pole, and the fiberglass itself is colored black, a hybrid pole can even be made to look like a carbon fiber pole. Now, another mystery term you might have heard of with water-fed poles is 3K carbon fiber. 3K is made by weaving bands of carbon fibers at 90 degrees to each other, like a fabric mat. Now, we call 3K an omnidirectional carbon fiber because the fibers are not all in the same direction. With half the fibers at 90 degrees to the other, the functional rigidity in the direction we want, which is up the pole, is only 50%. So no one would actually make a water-fed pole with every layer being 3K. 3K carbon fiber is actually added to the outer layer of your pole. That's the only layer you can see. And its purpose is to reduce the delamination of the unidirectional fibers. Now, it's the unidirectional carbon fibers that give us our pole rigidity. Unidirectional is only available for carbon fiber and not for fiberglass, because fiberglass is woven. Kevlar is the latest material in water-fed pole design. However, it does not have a high modulus. It is, like fiberglass, a woven omnidirectional fabric, and it's not even as rigid as standard carbon fiber. However, because it's non-conductive, 100% Kevlar is useful for insulation against heat and electricity, like we do with shock stop. To recognize Kevlar on a water-fed pole, it has this really nice, beautiful golden color. Now, as a side note to all this data, we want to bring your attention that your technique when using a flexible pole to clean windows is quite different to the technique you can master when you have a more rigid pole. When you upgrade your pole, make sure you also plan to change your technique, because your technique determines your efficiency and therefore your income. Now, the good news for some businesses is that there's one exception to this rule. It's when you're never cleaning windows at extreme heights. If you're only cleaning storefront windows with a squeegee, an aluminum pole is fine. At 2 stories, a hybrid water-fed pole could work with a manageable flex. It's kind of like that. But a 100% carbon fiber pole would deliver perfect results. I mean, you can literally feel the difference. So the rule is simple. The higher the windows you need to clean, the more rigid the composition of your pole should be to maximize the transfer of the power from your muscles to the brush, meaning you will be cleaning windows faster, better, and safer. If you enjoyed this Reach It workshop, find all the other topics at youtube.com/future of cleaning and subscribe to get notifications of each new topic, like we release them daily pretty much. If you prefer to listen while working, check out Reach It Workshop Podcast. And all of our topics are also available as a downloadable PDF for your training manual. Now, alternatively, register for our newsletter at futureofcleaning.com and get a weekly email with all the videos that we've released. Okay, that's all for today. We'll see you in the next Reach It workshop.